Thank you. Thank you very much. Okay, so I'm Dylan Walker. I'm an assistant professor at Boston University, and I'm going to talk to you today about identifying social influence through randomized experiments. And I'll start with just 2 words of motivation. The words are things, spread. And by things, I mean all of these things that you see appearing before you here. Things like innovations, rumors, diseases, behaviors, emotions, products. And of course, many different types of things we think have the capacity to spread. But I'm highlighting these ones here because they seem so loaded with economic significance. And we also have this idea, just looking at them, that we believe they can spread. The thing is, in any given scenario, how do we actually know that these things really are spreading? So let me be specific with what I mean by spreading. I mean to transfer from one individual to another through some kind of interaction or contagious agent. This is a picture of poison ivy berries. Poison ivy represents an interesting analogy. For those of you that aren't familiar, the berries and the leaves of the plant, they emit an oil called urushiol. And what happens is when this oil gets in contact with your skin, at first nothing happens, and then in about a week, you'll see a rash of fluid-filled blisters start erupting on your skin. And the way that it will appear is in this interesting type of spreading pattern. It first appears in the areas of your skin that receive the highest doses of urushiol, and then later in adjacent areas of your skin. And because of the way it appears in this slowly spreading pattern, people think, they're itching it, they think that the fluid in the blisters itself is a contagious agent. And they think if you contact it, you can spread it to other people. But that's actually not the case at all. What they're really seeing is the echo of exposure to a prior contagious agent. There's nothing left anymore that's causing the spread. They're just seeing the kind of echo, the remnants of that. What's really interesting is if you compare those patterns, and instead of looking spatially, look across a network and over time, you see the same types of spreading patterns. So here I'm showing you the adoption of a product on the Yahoo Instant Messenger network. And it's a little hard to see here, but the green nodes, like this one here, are new adopters, and I've highlighted the links to existing adopters in orange. And going from one time period to the next, you can see these patterns emerge. So we see these types of spreading-like patterns in a variety of different situations with things like product adoptions, but also with things like emotions or health-related outcomes like obesity. So is this really because things are spreading, transferring from one individual to another through a contagious agent, or is there some other explanation for this type of pattern that we see? So it turns out there's actually a variety of different alternative explanations that would lead to this type of behavior. Homophily tells us that birds of a feather flock together. We tend to be similar to our peers and thus may enact similar behaviors. There's also confounding factors. Friends are more likely to be exposed to the same stimuli, and that stimuli drives their behaviors in similar directions. And there are things like dynamic processes. So suppose my friend and I both want to buy the new iPhone 6, but it's too expensive for us. And now we know that Black Friday period is coming up, and the price is going to be lowered. So when the price is lowered, I buy the iPhone immediately, and my friend buys it within the week. It's not necessarily the case that I influence my friend to buy the iPhone, but rather that we're both responding to the same dynamic process, and there's some element or aspect of stochasticity in our time to response. You could ask, look, why do we care what causes these patterns? So my answer to that question is twofold. The reason why we care is that first of all, different causal structure implies different properties of diffusion, both in the conditions that we do see, but also what if conditions were slightly different? How would it diffuse differently? And secondly, it also suggests different optimal policies either to promote a positive contagion or discourage a negative one, something like a disease spread. And the truth is, this actually has dramatic implications for a variety of domains. So in marketing, there's this idea that if we knew who influential people were, we might like to target them in order to better spread the adoption of a product or service. In public policy, we may want to design social interventions, right? Like friends don't let friends drive drunk. That's a social intervention, in order to affect outcomes like obesity, smoking, or academic achievement. And in organizations, we might want to understand, do your peers working next to you make you more productive because they're more productive? Or do you just tend to become friends or peers with other workers that are more productive like you. So in order to address all of these different contexts, we have to be able to separate out the part of the spreading pattern that's correlational and due to these alternative explanations, and from the part that is actually causal, really due to influence. And the chief problem here is that statistical identification of peer influence or peer effects is really hard. It's a hard problem. To try to do that with observational data, there's many, many advances in doing this. They're all great works, and they really have advanced our understanding of how we can go about doing this, and we should by no means abandon that search. However, there's been some great work using randomized experiments in order to identify peer influence. I'm showing you some of these down here, both my own in conjunction with Sun, but many other people have taken this approach, and I think it's really fruitful, and that's what I'm going to be talking about today. So I'm going to tell you about randomized experiments on Facebook. It's not the only place I'm doing randomized experiments, but it's the focus for today. And I would actually argue that Facebook is really an ideal experimental environment in which to study peer influence. For one thing, it's out in the real online world. It's not in a laboratory. You'll notice I said online because I know that there are many aspects of our life, right, that are more important offline than they are online. But it's in the real world, and what I mean by that is it's not in the laboratory. The issue is that in the laboratory, we know we're being observed, and this can change our behavior. And beyond that, small changes in the environment of the laboratory can lead to huge changes in the observed outcomes of behaviors. So it's nice to be able to study things in maybe the context that you're actually interested in. So forget about Facebook for a minute. I want you to imagine that, take this methodology and apply it to any physical system that has the properties that are like Facebook. What type of properties do I mean? Where you have a large sample of individuals, say hundreds of millions, interacting on a daily basis, and where you can get detailed digital traces of both who they are and what types of things they do. Okay, things like demographics, preferences, political views or religious views and interests, how they're participating together in online groups, what type of relationship they're in the offline world. So any context that's like that, if you have experimental control like you have in Facebook, then you can do these types of things. For example, Facebook has all of these APIs that let you alter things or control conditions about how people interact using, say, an application that you designed or some website that plugs into Facebook that you designed. And these allow you to have the experimental control that you need to do these types of randomized experiments. They have a lot of advantages over the traditional kind of laboratory environment. They also have a lot of disadvantages. In fact, in one of my latest papers, which is coming out in Proceedings of IEEE, I talk in detail about the implications of setting on running randomized experiments. If we have time today, I'll come back to that. So the first work I'm going to tell you about is all about identifying influentials and susceptibles in online social networks. This is work with Sutta. It was published in Science in 2012. The focus here is not just on how do we figure out if people are influential or susceptible, but also what does individual heterogeneity really mean in terms of how things spread. So the focus is on differences amongst individuals. The second one I'm going to talk about is about differences in relationships between ourselves and our peers, okay? Tie characteristics. And finally, if we have time, at the end, I'll go into some design of experiments in networks, how you go about designing them, what are the main problems, why do networks really make us change the way we think about experimental design. Okay, so what are influentials? Well, influentials are hypothesized individuals that have disproportionate influence over others in the population. They're called things like opinion leaders, and they're often thought of as catalysts for diffusions of ideas or behaviors. And also, from a standpoint of policy, as ideal targets to promote or discourage some type of population-level social change. Now, Duncan Watts and Peter Dodds, they studied a lot of simulations of different models of social influence. And they said this quote here, which I think is really interesting, so I'm going to read it out. They said, in the models that we have studied, in fact, it is generally the case that most social change is driven not by influentials, but by easily influenced individuals influencing other easily influenced individuals. I want you to remember that quote, and by the end of this first part of the talk, we'll come back to it and look at it again and see if it can be true. But for now, this begs a number of questions. So the first thing it begs is, are some individuals really more influential than others? Do these people exist? Maybe instead, do susceptible people exist? And the issue here is, what is dominating the diffusion dynamics? Is it whether you're more likely to be influenced by a peer or whether you're more influential on your peer? Are those even two different things, or are they just two sides of the same coin? We'll come back to all of those questions. For now, the research questions I want to focus on are, how can we identify these individuals in the network using a randomized experiment to figure out who's influential and who's susceptible and to what extent? And what can this tell us about how things spread? And also, what is the point of this individual heterogeneity? How does it relate to the influence that we exert on our peers and that they exert on us? So the key challenge here is to simultaneously identify the influence-driven adoption of this product that we're going to watch spread and separate it out from the spontaneous adoption. That's all of the other things which aren't due to influence, but that lead to the types of spreading patterns we see already. So we want to identify both of those at the same time. And then we want to look at, once we can do that, how these things are spread out over the network. For example, are influential people all clustered together, or are they spread out? How are they connected to people? Are those people more susceptible or less susceptible? We'll look at that. Okay, let me get away from the abstract and tell you what the experiment actually is. So the experiment used a commercial-grade Facebook application. It was released in concert with the beginning of the experiment. And then we recruited initial adopters of this application through a Facebook advertising campaign. We actually took a lot of great pains to ensure that this was a representative sample of Facebook. And there's tons of supporting material to prove that. But luckily, I don't have to show it to you here because it's pretty boring. So then, as the users used the application, notifications about their use were automatically generated. So-and-so did this, okay? And then delivered to randomly chosen peer recipients from their list of all their friends. I call this procedure, it's a randomization procedure, and I call it message target randomization. I'll explain that in more detail with a picture on the next slide. So once we did that, we tracked the time-stamped adoption and use of the product for individuals and their peers. Here's some stats about the experiment. It was conducted over about 40 days. About 8,000 product adopters sent about 40,000 of these automated messages to their 1.3 million peers. And this resulted in about 1,000 adoptions. It turns out that number is actually economically significant relative to what we could have expected with no type of influence mediation at all. So I promised I'd tell you, what is this message target randomization? This is really the key part that we're randomizing in the experiment, and I think it's pretty interesting. Later, when I talk about randomized experiments in general, I'll talk about randomizing treatment, which is a little different. But for now, let's focus on what is message target randomization. So the experiment uses notifications, which are passive messages. That means that when you're using the application, you don't have to do anything above and beyond just using it in order to send a message to your friend. In fact, you don't get to say who it goes to or when it's sent. We get to say as the experimenters. So what happens is, and I'll explain it to you in this diagram, at time t1, a packet of notifications is generated by this user of the application shown in blue. Here's all the user's friends. A very short time later, we pick some random subset of the peers to receive the notifications in this packet. This happens again later. Notice here at t4, we didn't pick the exact same subset of peers, but again, a random selection. So if you're a peer of one of these users of the application, at any given time throughout the experiment, you have received 0, 1, 2, or maybe more notifications from your friend who's an application user. This we call NJ of T. I'm always going to use the letter J to refer to a peer of someone who's using the application. And I'll use the letter I to refer to the individual that's already adopted the application. NJ of T is the number of notifications that a peer J has received, and it reflects her risk group, the extent to which she's been exposed to influence mediating messages from her application user friend. This is not the application we used, but it's a really similar application. Yeah.
Dylan, very quickly.
Yeah, sure.
That last setup,
sure, yeah.
design, how do you control for other adoption-relevant information that those peers may be receiving from outside your experiment?
We don't do that. We did a lot of diagnostic tests to see whether or not that had an effect, and we could not find any signal whatsoever about that. But you're right. There could have been, I could have called my friend on the phone and told him, hey, there's this really great application.
Mm-hmm.
Right, so that would be bulked into the non-influence driven part. So what we definitely identify is how influence-related adoption is driven by this particular channel of influence. You could test this on many multiple channels if you had the ability to track that. That's a key disadvantage of online experiments. You lose that experimental control. In the lab, you would be able to say, you can't talk to anybody else, right? But here, we don't have that experimental control. So yeah, you have to kind of look at many other types of proxies for that type of signal, like, for example, did they adopt any applications during this period of time to see if maybe that was a likely alternative explanation for the spontaneous part. But for the influence part, at least we know we identify that. But yeah, that's a great question. So this isn't the application we use, but it's a very similar application. This is if you were a subject and you have already adopted this, you would see this type of view. You could say you wanted to view a movie or that you like a particular celebrity and things like that. If you're a peer of one of the subjects of the experiment and you get one of these notifications that mediate influence, at least this used to be what it looks like. It doesn't really look like this anymore. You know, Facebook changes. You had a little inbox down here and it would get a big exclamation point if you had a message. And inside you'd get the message here. If you clicked it, you would be taken to a page where you could install the application. Note, the application is free to install here. So that might change. You know, I'm not claiming that what we find here is not dependent on context. It does depend on context. What I'm claiming is this is the right methodology if you want to go about understanding how things spread. So how do we go about estimating influence given that we've randomized sending messages between individuals and their peers? Remember, we want to simultaneously estimate influence-driven adoption and spontaneous adoption. And we're really interested in individual heterogeneity. So the three things that I'm looking at here are age, gender, and relationship status. How does that affect how influential you are or how susceptible you are to influence? The approach we take is using a single failure proportional hazards model. I don't know how many of you are familiar with hazard models. They're used all over the place in clinical medicine, usually when you have a population that might die, right, or be affected in some irreversible way. It's a survival model. It takes use of duration data. And in this case, in the lingo, each particular peer of an application user can adopt the application. In the lingo, they can fail, okay? And what we do is that we have this NJ of T number, which is monotonically increasing randomly throughout the experiment, okay? So we use something called interval censoring. So if at time 0, you had received one notification from an application user friend, and at time 2, you suddenly receive another one, you're censored out of the NJ equals 1 risk group and into the NJ equals 2 risk group. So that's how we handle this randomization changes. The model of influence and susceptibility looks like this. Lambda is a hazard to adopt. It means conditional that you didn't adopt the product already. At this instant in time, what is the probability that you will adopt? It's proportional to some baseline function, which we don't even have to specify. It's totally arbitrary. To teach this model, to train it, we don't need to say what lambda 0 of t is. We can reconstruct it later, though. And then let me go through and explain what these different terms are. So the first thing you'll notice is a coefficient sitting in front of this nj of t. This captures the raw impact of receiving influence-mediating messages on the peer's hazard to adopt. This is irrespective of any values of individual attributes. It's just the raw amount. Notice that if nj were equal to 0, this term would vanish, right? It doesn't exist if there's no influence. Now we've got some spontaneous terms. I say spontaneous because they don't have anything to do with nj. When nj equals 0, they still survive. The first one, this xi here, is a placeholder for all of the attributes of I, the application user. So this is about spontaneous adoption that's correlated with the attributes of the sender of the message. For j, now we're looking at the attributes of the peer. This is spontaneous adoption. Again, when nj equals 0, this term survives. This captures the impact of individual characteristics on the peer j's hazard to adopt spontaneously. And then we have the two terms now crossed with nj. So these are influence terms. I call the first one an influence term because it's all about the sender of the message influencing the peer to adopt. And it's moderated by the values of the characteristics. It's a per message received type of estimate because if nj equals 2, this number is estimated for, per message received. And finally, we have the susceptibility part, because this is about the characteristics of the peer on whether they will adopt given that they've received a message from their friend per message received. Does that make sense? Yeah.
Why would the second term of just the individual using the application serve survive if they haven't received anything from?
Because you can go and adopt the application even if you've never heard about it. There's a directory of applications. You can go look at them. Yeah, there are other ways that you can adopt. Great question. Yeah.
I have the same question, but I'm not sure I followed the answer. So the I refers to the sender of the message, right? But if the
That's
sender
right.
has not sent messages, why should his characteristics, which XI represent, why should they play any role?
Okay, that's a great question. So it's like saying, if my friend likes baseball, even if I don't declare my like for baseball, maybe I'm more likely to adopt this application. If I'm friends with a bunch of people with these characteristics, I'm more likely to spontaneously adopt. Yeah, it'll become even more clear when we look later at tie characteristics what this type of thing means. It's like a preference similarity. Given that you're a friend with someone who's adopt, how do their characteristics link to your tendency to spontaneously adopt? Yeah.
Your baseball example is sort of assuming, though, that the information is kind of out there, right? That people know about baseball, so they could pick
That's
up
right,
who's
yeah.
watching baseball.
Yeah, you could, in fact, adopt this application
So
spontaneously.
what's the mechanism through which they're learning about this application without the friend telling them about it?
You could just search the application directory on Facebook if you were looking for by type of application at the time, and you could discover this application, right?
Isn't that that's a pretty high bar, though? 'Cause
Actually, we find a fair amount of spontaneous adoption. You'd be surprised. It's sort of, when I talk about this, because it seems so unlikely also to me, I give the example of like the dancing monkey on the internet bar that no one clicks on, but it's still there, and it generates like millions of dollars of revenue. Right, so I don't understand it either, but lots of people, were heavy users of Facebook applications and went to the directory and found these different
It just seems
applications.
different, though, than somebody saying, hey, you should watch, this movie that just came out.
Yeah,
Which you could, the likelihood of just going to see a movie on Friday night and watching that movie is still pretty high, right? Whereas
I agree.
finding an application that the
Yeah.
search costs are much higher than adopting, or
I think they're not as high as you may think, but I agree that it probably happens much more frequently with movies, for example, than it would be with Facebook applications at the time. A lot of people at this time, Facebook wasn't so flooded with applications, and I think a lot of people have now a negative kind of spammy attitude towards them. But at this time, I think people were actually searching for things to do on Facebook. So I think our behavior has really changed since this experiment was run. But nonetheless, I think we really do see a fair amount of spontaneous adoptions. I don't know if I actually show those bare here in a plot, but if you want, I can find them later. Yeah.
Can any J be influenced by multiple I's, or is there one-to-one?
Right. That's a really great question. No. So we don't look. We censor people out of the experiment as soon as that can become possible. And the reason why is we don't know how influence adds together. If I get to the third part of my talk, I'm going to talk about how we deal with those types of problems. Discover how things add, how they decay across social distance, right? It's a really, really important point. We kind of took the baby steps approach here. We're just looking at the first step. Other things happen too, like selection bias. See, once you have somebody who's already adopted the application in your local network, that may say a lot about what type of person you are, and therefore treatment might no longer be random. Yeah.
What about the time frame after I receive a notification? I think I'm much more likely to adopt it in like the 5 minutes I receive it than like.
And then not at all after some period of time.
Yeah, so there should be decay involved here also.
That's right. So that's not the assumption of a proportional hazards model. In fact, we actually don't see a very strong decay. Either people will adopt or not adopt, not have a decreasing. In other words, I think either they respond within a short period of time or really not at all. But I don't think that translates into if it's not at all, then it's just zero value, right, contributing to this model. We tested the assumptions of proportional hazards, and they pretty much fit. The one place they start to fall apart is when NJ becomes really high. Because after you've received a certain number of notifications, you're like, look, I already know about this. I'm not interested, right? And so you have a sort of decreasing nonlinear response to NJ after it gets that high. We don't have many cases actually where it got that high, though. Okay. So let me describe some of our findings from this first part. So this plot might look a little funny to you. A hazard ratio of 1 is compared to the baseline. Remember I showed you that lambda 0? So none of the terms are contributing here. And I'm going to show you the impact of each of the it's the exponentiated coefficients that I showed you on the last slide that translate to the hazard ratio. It's basically a number. If it's higher, right, it means your peer was more likely to adopt. If it's lower, less likely, okay, in a short period of time. So the age characteristics are split out. Undefined is the baseline. So you see, for example, male and female appearing together. That's because you might not specify your gender on Facebook. Same thing with relationship statuses. There are a bunch of different types that you see. There are actually more, but we never saw any of those in the data. So here's what it looks like. The bars here, the center points, are the actual hazard ratios. The bars surrounding them are the robust errors, and then the whiskers are the confidence intervals. A good rule of thumb is that, you know, if you're not touching this bar of 1 down the middle, you're likely to be significant. You also have to compare differences between these variables, obviously. So people over the age of 31 are the most influential. Maybe that surprises you on Facebook. I like it. And they're the least susceptible to influence, okay, about 18% less than the baseline. Single and engaged individuals are significantly more susceptible to influence. I like to think that engaged is all about being in that transition period of your life and you're just willing to listen to more people about more things, but I don't know. And single and married individuals are significantly more influential. We can also look at dyadic results. So now I didn't show you this model, but I'm recodifying things to look at relations between individuals and their peers with respect to their demographics. So for example, you could be younger, the same age, or older than the peer that you influenced. It could be a guy sending a message to another guy, or a girl to a guy, etc. And the level of commitment of your offline relationship, not with the peer, but with whoever your partner is, could be a lesser level, an equal to, or a greater level of commitment. What we find is that people exert the most influence on peers of the same age, probably not all that surprising, and tend to exert more influence on younger peers, but just by a little bit, and in fact, this really isn't significant. You can see the whiskers crossing the baseline there. Men exert 26% less influence on women than baseline users do on their peers, and women exert 67% less influence on other women than they do on men. Finally, individuals are more influential on peers who are in relationships of lesser or equal levels of commitment. Remember, that's controlling for age, okay? It's kind of, to me, that's interesting. Controlling for whether you're younger or older. If you're in a more committed relationship than the person you're sending the message to, you tend to be more influential on them. All right, this is going to get a little bit hairy. So I'm showing you how influence and susceptibility, both of an individual and also of their peer, are distributed on the network. So this is a heat map. In each bin of the X and the Y value, its color refers to how many people had these values. So first, I'm just looking at an individual. Forget about their relationships. What is influence of an individual? How does it compare to their own susceptibility? It turns out that influence and susceptibility kind of trade off. If you're a very influential person, your distribution of susceptibility tends to be much sharply peaked. You tend not to be susceptible to influence. If you're not very influential, you tend to be a little bit more susceptible to influence. You can also say, hey, look, is being influential the same thing as just having a bunch of peers that are susceptible? Are these just two sides of the same coin? It turns out that the answer is no. People who have high influence have approximately the same distribution of susceptibility amongst their friends as people who have low influence. So it's not just two sides of the same coin. These hypotheses that there are influential people and susceptible people in the population are orthogonal to one another. They can coexist. This plot down here shows you whether or not influentials cluster. Given an amount of influence for an individual, what does the influence of their peers look like? You see this peak right up here, greater than 1? It means that influentials tend to have friends that are also influentials. What about susceptibles? The really susceptible people, you know, easily influenced people, do they influence other easily influenced people like Watson Dodds said? Maybe, in general, that could be true. In this particular context, there aren't any people here. There's no clusters. In fact, people that cluster together are stubborn people cluster together, at least with regard to this context. This is really interesting. We can start to see what's driving diffusion behavior. Is it really about easily influenced people influencing other easily influenced people, or is it something else? Finally, I can sample each point in the space this point A is the same point A up here. It's in a different place because I'm looking at different axes, okay? And I'm sampling a network and saying, what does that network look like? And we get many different answers for this. And these would tell us, is this a good candidate for propagating a message? Should I immunize this person, for example? Something like that, right? I size the nodes in proportional to their influence. Bigger nodes are more influential. It's kind of tough to see actually here. There's some bigger pictures of this somewhere else. So bigger nodes are more influential, and I color them the more red if they're more susceptible. So you see, you can have a person not very influential with a few very susceptible peers, but mostly peers that aren't susceptible. You can have someone with a moderate level of influence surrounded by a ton of very susceptible peers. I would love to have these pictures if I'm trying to decide who I should immunize, who I should send a free product to, or whatever change I'm trying to institute, whatever message I'm trying to spread. These pictures facilitate properly seeding that message. We haven't explored that, I think, fully yet, and that's something that we're doing. Yeah?
Dylan, just very quickly, I've lost the time dimension a little bit in terms of adoption through time. So
Yeah.
did you guys find that the really susceptible people are the first to adopt?
So that's coupled into the hazard,
Uh-huh.
right? So that score already measures. Hazard is the assumption that if you wait until infinity, you will adopt, right? The only question is with what chance. So a higher hazard means a bigger tendency to adopt quicker is the way to say it. Since you're always going to adopt at infinity, it kind of already encompasses. I should have said, by the way, we extrapolated the scores to make these
Dylan,
pictures.
the question there, though,
Yeah.
is, like, if you're considering time of adoption to be a proxy for being susceptible to influence,
Mhm.
then how do you know it's really about being susceptible to influence and it's not just early adoption-like behavior? Maybe they're avids.
I agree, except remember, this is contingent upon, this is only the piece of the model that accounts for a message that was randomly sent between you and me. So if there were avids, they should be the same in the cases where the messages weren't sent to peers as they would be where one message was sent, where two messages were sent, etc.
True, unless you say to yourself, well, the message being sent raised the awareness for the avids that it actually exists. So it wasn't like I was influenced by you. I simply became aware of it because of you, which is different than...
Then we have to, I think then we have to wonder, what does influence really mean? Is that maybe part of influence, raising awareness? So I don't know the answer to that question. If you want to say influence doesn't include me raising your awareness of a product, yeah, then I'm not sure what it means. I guess I would fall back to the definition, which is to say the impact of the message that I sent you, whether it was to raise your awareness or whether it was, oh, it's coming from Jim and Jim knows all about this great applications, so I should listen to him. Whatever the reason is, I think it's coupled into that. But to distinguish those two things is really great. We actually did some tests to try to assess whether people were more or less aware. We didn't find any signal there. I don't think that's really sufficient to prove that that's not the type of influence that's going on here. But personally, I would still categorize that as being influential. I wanted to mention that in these plots, I'm not just using the 1 million people. We had data on 12 million people, so I'm extrapolating for all 12 million people in the population and calculating their total score. So an influence score is based on all of your characteristics. I combine it into one number, which is a multiplication of the hazard ratios for each of the ones associated with the different traits that you have. Okay? Okay, look, context matters, but the method's general. Women are more influential over men than men are over women. Older users are more influential over younger users. This isn't for everything in the world. This is for this one thing we tested. I want to make that really, really clear. Okay? I don't know if it's universal. I pretty much doubt that it is because, buying a car is not the same thing as adopting a free application on Facebook. It's not the same thing as soliciting someone for kind of like life or relationship advice. They're all very different contexts. And I have no reason to believe that they'll be the same results. What we found that I think is most interesting is that influence and susceptibility tend to trade off. I wonder if that's always the case in every context or not. The two things really aren't two sides of the same coin. They're different hypotheses. They're orthogonal from one another. And finally, influentials cluster in this case, but susceptibles don't. I really wonder if you could build kind of like a categorization of different types of contexts where influence could occur and whether you would find different clustering patterns with regards to influentials and susceptibles in those different contexts. Let me just do a quick time check here. I have, okay, about 10 more minutes. Okay, so let's focus instead of on individual characteristics, on relationship characteristics. So I've already, I hope, convinced you that individual heterogeneity matters, but what about relationship heterogeneity? Our relationships aren't identical, right? They have a social context to them. How did you meet? How do you interact? How frequently? Do you share similar interests? Are you close? Is there some type of mutual trust? So two widely studied tie characteristics are embeddedness, which here we codify as the number of common friends that you have with a peer is how embedded you are. There are slightly other variations, other ways to do that. And also tie strength, which is a notion of closeness that combines things like interaction frequency, emotional intensity, intimacy, and things like that. And this is really important, both of these, because they're theorized to affect trust, altruism, cooperation, truthfulness, perceived importance, intensity, intimacy, right? Information exchange. So, in fact, a lot of people have already studied these. The impact of tie characteristics on influence itself have been widely studied. The problem is that in many of these studies, they didn't control for the communication patterns between people and how they relate to these tie variables. These are endogenous communication patterns. Let me show you what I mean. What I mean is that the frequency and nature of communications depend on tie characteristics. Maybe if you have a stronger tie with someone, you communicate more frequently with them, right? Maybe if you're more embedded with that peer, you communicate more frequently. I want to know what is the impact of sending an influential message while holding that constant. So the challenge here is to control all the other stuff we've talked about before in terms of individual heterogeneity. Now look at relationship heterogeneity while holding this endogenous communication patterns constant. Fortunately, we already have the answer to this because the message target randomization is completely random and doesn't relate to tie strength. So again, we can already use this to estimate the impact of both embeddedness and tie strength. So let me elaborate. Well, what I mean by tie strength is probably a less conventional definition. I'm looking at different types of relationships because tie strength involves not just frequency of communication, but other things that characterize the relationship. So here we look at photo co-appearance, how many photos you appeared in online with your friend, whether you come from the same hometown, whether you currently live in the same town, whether you went to the same college or a different one, and how many common affiliations, groups, and pages you have. Affiliations reflect offline affiliations like, I don't know, going to Kellogg would be an affiliation, right? Being part of NICO would be an affiliation. And groups, you can participate and talk to one another on Facebook in these online groups. And pages are things like things that you like. They can be affinities for brands, celebrities, media personalities, bands, etc. So again, we use this hazard model, so you should already be familiar with this. Let me just show you the new terms that are appearing here. So I'm controlling for spontaneous adoption that's now related to embeddedness. Remember, this is like a preference similarity. Given that my friend I already adopted and were this embedded, does that indicate my preference to spontaneously adopt or not? Same thing with these different measures of strength of tie, okay? Two terms for the spontaneous adoption. And now we get to influence related to embeddedness between individuals and influence between individuals related to strength of tie. These are multiplied by nj. They would vanish when nj equals 0. So it's the same type of modeling approach exactly, only now we're looking at tie characteristics. So let me show what happens here. So individuals exert 125% more influence on peers for each affiliation that they share in common. They exert 14 times more influence on peers with whom they attended the same college. That's incredibly big, okay? 14 times more likely that they influence your action if they went to the same college. And about 6 times more influence on peers that live in the same current town. So recency of your relationship on Facebook matters. What I find that's really interesting that I'll get to in a minute is that it turns out that past relationships actually indicate more preference similarity. Like where you came from is like what you're interested in. If you step back and think about it, the difference between homophily and influence is really a matter of time scales. What is influence at the short-term scale shapes your personality. You homogenize with the people that you're surrounding, you assimilate with them, and it becomes your preference overall, okay? So a way to think about the fact that these two things, homophily and influence, are really confounded is to say, really they're two different temporal aspects of the same dynamic. So we find a 0.6% increase in influence for every friend that you share in common, which may seem like nothing, but the number of friends you can share in common with someone can be quite large, typically dozens to even hundreds. And photos together, common pages, and common groups don't actually matter with regard to influence. I was really surprised with the photos result myself. If we turn around and look at spontaneous adoption, preference similarity, we find that a lot of these things like common affiliations, same college, same current town don't matter in terms of your preference similarity. But what does matter is coming from the same hometown as someone who's adopted this product is associated with about 100% increase in hazard to spontaneously adopt. And of course, being embedded now matters not just for influence, but also for spontaneous adoption. Having a lot of common friends probably means that you share some similar preferences to a particular friend of yours. Appearing in photos matters for spontaneous adoption, though not for influence. And then also pages and groups. So again, context matters, but the method is very general. Social relationships based on common experiences like same college or common affiliation are associated with the strongest influence. Relationships that are based on some types of recent experience, not all, are associated with strong influence, while other things like photo co-appearance don't. And I think one of the explanations for why that is that you're already controlling for all of these other factors. So the added information that the number of photos you appear in with a friend adds to the picture tends to be quite small when you know about all of these other things. Okay, I don't think I'm going to have time to discuss designing randomized experiments. Maybe I'll just jump to one slide to explain a quick idea here. The problem is that we want to run a randomized trial where we give all the people in the treatment group a pill and all the people in the control group a placebo. But it turns out that everyone's connected to one another. And this method of dividing up the population randomly and treating some people and not treating others depends upon this assumption called Sutta. It stands for the stable unit treatment value assumption. What it means is that I don't care whether you treated my friend or anybody else in the population. I don't care how you treated them. I just care how you treated me. If that is no longer true, then we've got a big, big problem, and it goes all the way down to the kind of fundamentals of the scientific method. So we need to figure out a way to solve that. It turns out that there's lots of approaches to solve this using analysis. I'm not going to tell you about them because I don't have time. But you can also solve this by design. So here, I want you to imagine that a treatment is something that affects an individual's experience. Okay, so I can either treat you one way or maybe many different ways, and it only affects your individual experience. But it could have some type of indirect effect on your friend. So how should we allocate our treatments across a network? One strategy says cluster them together. Another strategy says spread them very far apart. Both strategies have their advantages. In particular, it depends on what you're interested in. Some people are interested in understanding co-treatment. For example, if you're on Facebook and you're using a messaging app, you want to test, is this a good feature for the messaging app? It only makes sense if all of your friends in your local network have the same feature. Because if they don't, you don't really know whether that would be an effective feature or not, because they can't really use it because their friends don't have the same thing, right? So that's called the effect of the treatment on the co-treated. For things like treatment clustering strategies, they're really good for making inferences on that type of impact of treatment. But if you want to understand fundamentally how things add together and spread, a good way to do it is to spread your treatments out far apart from one another on the network. Some people have theories about how far you should do it. They define a distance over which they say social influence should no longer matter. They call it the Sutta distance. This is work by Kopak and Sirkar. You can actually they have a great method for how to do this algorithmically on a network. And in fact, while they haven't explored this yet, you can adapt this to really understand how things add together, how influence from multiple sources might add together, and how it decays across social distance by picking motifs exactly like that, putting them in the network in certain places, and isolating them far from all the other treatment nodes. This is a really complex thing to do in practice. There are great algorithms to do it, And a lot of testing needs to be done to really assure us that we're really getting around this statistical interference effect between units. Okay, that's all I wanted to say. So questions?